The shape of efficiency, what a piece of thread reveals about nature.
Science Makes Me Smile, presented by young Dr. JGC, a creation of old Dr. JGC.
I am young Dr. JGC. Let's begin. Length or shape, which is more related to the area of a surface. It is natural to assume that a thread of a given length, when arranged to form the boundary of a surface, will always enclose the same area regardless of its shape. According to this intuition, the only factor that should matter is the length of the thread itself. This intuition, however, is completely wrong. In fact, this simple observation teaches an important lesson. Our first intuition is not always correct. The following is a short demonstration that the area enclosed by a certain length is mostly dependent on shape, not thread length. Consider a 30-inch thread folded into a rectangle with a length of 10 inches and a width of 5 inches. In this configuration, the rectangle encloses an area of 50 square inches. If we gradually change the shape, reducing the width while increasing the length, the perimeter remains constant at 30 inches. The thread length doesn't change, but the enclosed area decreases. As the width approaches zero, the rectangle becomes degenerate, with sides 15, 15, 0, 0 inches. The perimeter stays 30 inches, yet the enclosed area collapses to zero, illustrating how a shape can maintain the same boundary length while enclosing no space at all. Another interesting fact about shape and perimeter is that for any given polygon, triangle, rectangle, pentagon, hexagon, and so on, the regular polygon, with all sides equal, encloses the largest area for a fixed perimeter. For example, a 20-inch thread can form a rectangle measuring 8 inches by 2 inches, enclosing 16 square inches. If it forms a 6-inch by 4-inch rectangle, the area increases to 24 square inches. When it forms a 5-inch by 5-inch square, the area reaches 25 square inches, the maximum possible for a rectangle with a 20-inch perimeter. This shows that for a fixed perimeter, greater symmetry leads to a larger enclosed area. This slide further demonstrates that it is not just regularity that matters, but the degree of regularity or symmetry. The closer a shape is to being fully symmetric, the larger the area it can enclose for a given perimeter. Another important observation is that for a given perimeter, the more size a shape has, the larger the surface area it encloses. For example, a regular pentagon encloses more area than a square with the same perimeter. A regular hexagon encloses slightly more area than a regular pentagon, and this pattern continues as the number of sides increases. In the limit, as the number of sides becomes infinite, the shape approaches a circle. The circle, in fact, encloses the largest possible area for a given perimeter, making it the ultimate example of geometric efficiency. This principle helps explain many forms we observe in nature. The human cranial cavity is roughly spherical, allowing it to contain more brain tissue within a given boundary. Many free-floating cells in the bloodstream are approximately round for the same reason. Circular and spherical forms are highly efficient ways to enclose volume. Gravity also shapes large celestial bodies into spheres. The Earth, the Moon, the Sun are round because the sphere is the most efficient and stable form for containing mass under the influence of gravity. What begins as a simple piece of thread ultimately reveals a profound truth. Shape matters. The same boundary length can enclose vastly different amounts of area, and nature repeatedly favors the shapes that do so most efficiently.
Now you see why shape alone can redefine the space inside, even when the boundary stays the same. Fascinating, isn't it? Please let us know your thoughts about this episode.
Thank you for watching Science Makes Me Smile. Remember to like and share with a friend.